is on the fact that maybe their exponent isn't to the first power, and their graphs aren't going to be straight. So speaking of that, it says consider the function that is the value x squared. So, do you think the function is linear or nonlinear? Well, if we're talking about something, such as y equals x squared, we're taking the number x squared, we would think that there. Well, it's raised to a power other than 1. Right. So it says develop a list of inputs and outputs of the function and organize your work in the table and the questions. So our input is -5. We're going to square that to get our output. So I'm going to take -5 to the second power, which means -5 times a -5, which equals 25, positive 25. We're going to do the same thing for -4. Negative is a positive 16, -3 squared is a positive 9, -2 squared is a positive 4. Again, -2 times -2. -1 times -1 is a positive 1. 0 times 0. And then when we look here, now we're getting into the positive. So same thing. This is 1 squared. 1 times 1, which is 1. 2 squared, which is 2 times 2, which is 4. 3 squared, which is 9. 4 squared, which is 16. And 5 squared, which is 25. And what this does is it gives us a whole bunch of ordered pairs. -5, 25, -4, 16. So what we're going to do is we're going to take these points and we're going to plot them on. Go ahead and do that now. -5, 25, -4, 16, -3, 9, -2, 4, -1, 1, and go then 0 to get a curve along this line. Now watch what happens. Our input is 1, we go up 1. Our input is 2, we go up to 4. So you can see is that it's going to start coming right back up. 4, 16, 5, 25. Okay, so now we get this shape right here, which is in a straight line, which hopefully doesn't surprise us. So on the next page of notes, it asks us, well, what shape does the graph appear to take? Well, if we look at this, we see it's like a U shape. Which we know, or we have learned, is what we say a parabola. Okay, that U shape is a parabola. Okay, so find the rate of change using rows 1 and 2 from the table above. Let's talk about this. Rate of change, we've heard that term before. That's another phrase for saying unit rate. And if we say unit rate, that's another way of saying slope. So what I need us to do is remember the slope formula. Okay, and our slope formula, remember, is the difference in our y's, y sub 2 minus y sub 1, over x sub 2. Now, 1 and 2 here above or on the other page. So we're going to be points. -5, 25, and -4, 16. So the x coordinate, this is the y, this is the x, this x 1, x sub 2, y sub 2, second do that, then it's just a matter of plugging things. So y sub 2 is 16, y sub 1, which is 25, sub 2 to 4, minus x sub 1, negative 5. Remember, subtracting, we should change it to addition, so I'm going to go keep, change, change. Subtracting is the same thing as adding the opposite. So whether you think of it as 16 minus 25 or 16 plus a negative 25, we get negative 9. If I do keep, change, change here, negative 4 minus a negative 5 becomes negative 4 plus 5, which is just 1. So we get a rate change, unit rate of. Now we're going to do the same thing. So rows 2 and 3, remember, we're going to use again row 2 here, which was negative 4, 16, and row 3 is negative 3, 9. Negative 4, 16, 9. Now remember, you pick one to be your first point and one to be your second point. And then we selected to be minus my y 16 over my x sub 2, which is a negative 3, minus my x sub 1, which I said was a negative 4. Following the example, change, I end up 9 plus a negative 16, or just, 9 minus 16, however you want to think of it. That's a negative 7. Keep, change, negative 3 plus 4 ends up being just 1. So we have our rate of change, our unit rate, our slope as negative 7. So if we return to our initial claim, and our initial claim was, no, this is not a linear function. Okay. Were we correct? Is it linear or non-linear? And we're going to see again this a little bit differently, or kind of bring back some past knowledge. When we talked about things being proportional, which led into our talks of being linear, we always have to, if you think back to talking about our case, straight lines, proportional functions always have the same constant or the same slope. Well, if you look here, this is the same graph, but they have different slopes or different rates of change. So it's non-linear because we have change. Another term for slope.